everybody, welcome to video 2 for cumulative packet number 11. So where we left off was here at number 6, and we talked about that if a quadratic has a root or an answer of 2, if you think about factoring backwards, it came from x minus 4, because if you set that equal to 0, you'd get back here. And if you have an answer of negative 7, it came from x plus 7. We're not done with this problem yet, though, because we still need a quadratic, so we need it to say x squared. So if I want to multiply these, I can use the distributive property twice. So if I multiply x first, that would be x squared plus 7x. And then if I distribute the negative 4, I'd have minus 4x minus 28. So then my final answer as a function will be x squared plus 3x minus 28. And because we want an equation, I'm going to go ahead and say that f of x, which means another name for y, equals x squared plus 3x minus 28. So this is my quadratic function that has 4 and negative 7 as answers. Number 7 is somewhat of the same idea, except I don't want to write it as x plus 2/3 because I don't want to deal with the fractions. So just for a second, let me think about this before I start. If I had something and I factored it and I got, I don't know, something like 2x plus 5 equals 0. If I solve for x, I would have to subtract 5 first. So I'd have 2x equals negative 5. And when I divided by 2, I would get an answer of negative 5/2. The reason I'm doing this is to point out to you that notice that when you solve for x, the 2 is on the bottom. And the 2 was originally by your x before you solved. It would make sense the 2 is on the bottom because you eventually had to divide to get rid of the x. And the number that you moved over was on the top. So if you think about that logic backwards, if I have a 3 on the bottom here, that means that the 3 originally must have been attached to the x, kind of like how this 2 was attached to this 2. Now on this problem, the minus or the original plus became a negative in the end, kind of like how a positive 4 ended up being a negative 4. So this would be 3x plus 2 because my answer is negative, and the signs reverse. If I were going to do 3/4, the 4 is in the denominator, which means it's divided. So it would have to be by the x, but because my answer is positive, it originally came from something that was negative. And so these would be my two factors that don't have fractions in it. And if I would like my final answer to look like this in black, I would have to, again, distribute the 3x first. 3x times 4x is 12x squared. 3x times negative 3 is negative 9x. If I then focused on the 2, 2 times 4x is 8x. 2 times negative 3 is negative 6. If I combine like terms, I get 12x squared minus 1x minus 6. So my function is 12x squared minus 1x minus 6. And I know it's quadratic because the highest power is 2. So if I continue here with number 8, 8 and 9 both ask to factor each expression completely. Notice that neither of them are equations, they are just expressions, so I just need to factor and solve. So when I factor, you might remember the first thing I look for is the greatest common factor. The next thing I look for is perfect squares. Then I look to see if I have a lead number of 1, and if nothing else works, I have to split the middle term. And you can definitely get your factoring flow chart out if you'd like. If I look at number 8, it looks like I do not have a greatest common factor I can take out of any 3 of them, so that's a no. The first and last terms are not perfect squares. I do not have a lead number of 1, which means I have to split the middle term on number 8. In order to split the middle term, the first thing I do is multiply the a times c, and I get negative 30. And then I find all the pairs that multiply to be 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And then I ask myself, which one of these pairs can combine or add to be a positive 13? Well, I have 2 options here. Either this or this one can become a 13. But remember, we want it to multiply to be a negative 30. So let's try both. If I want positive 13 out of this pair, that would be 15 minus 2. And negative 2 times positive 15 is negative 30. So that might be our winner. But just in case, let's check this one. In order to get a positive 13, both the 3 and the 10 would have to be positive. Because positive times positive is not negative, this is not my pair. And so the reason, again, the method's called split the middle, because I'm going to take that middle term and split it into my correct factor pairs. So I'm going to write this as negative 2y, because there's a y attached, plus 15y, based on my correct pair. And I'm going to bring down the 10y squared, and I'm going to bring down the 3. The reason now we created this is so now that we have 4 terms, we can factor by grouping. So if I look at my first 2, I notice that my greatest common factor is a 2y. So if I take that out of both, 10 divided by 2 is 5. Y out of y squared is 1y left. Negative 2 divided by 2 is minus 1. Y divided by y is gone. Close parenthesis. If I look at my second pair, the greatest common factor is going to be 3, and I'm going to carry down that plus sign. So I'm going to take out a 3. 15 divided by 3 is 5. The y stays. Negative 3 divided by 3 is negative 1. So now that these two parentheses match exactly, my answer would be the following. 5y minus 1 is one factor, and the other factor would be what's remaining after I take this out, which would be 2y plus 3. This is an excellent answer, but just to remind you, it is okay to have the parentheses in the other order. This is also a correct answer. If I look at number 9, let's first look to see if there's a greatest common factor. No, I can't take anything out of both 16 and 81. Do I have perfect squares? Well, if I look at 16 and 81, yes, they are both perfect squares. And I notice that I have an x to the fourth, or a quartic equation. So let me bring down this work here so there's enough room. Let's see what we can do if we have perfect squares. 4x squared times another 4x squared would give me 16x to the fourth, and 9 times 9 would give me 81. In order to get a middle term of 0, I have one of these parentheses being positive and one of them being negative, because that's how my middle terms cross out. Some of you might recall that when you're left with two parentheses, both of which being squared, one of them is going to be able to factor and one of them will not. This one, when I have a plus sign, is the one that cannot factor any further, because notice in this previous, before we simplified it, that my middle term was a negative and we were able to factor. A positive would not work, because if you think about positive and negative, there's no way that a positive and a negative can ever be positive. So I cannot factor 4x squared plus 9 anymore, but I can factor the second parenthesis because I notice again that I have perfect squares on the ends. So if I continue factoring this, 2x times 2x is 4x squared. 3 times 3 is 9. My middle term is 0, so I want another plus and minus. So my final answer, if I wrote it more neatly, would be 4x squared plus 9 in the front, and then 2x plus 3, 2x minus 3. And no, I do not need to set anything equal to 0 because this is not an equation. It's an expression. Simplify the polynomials. Please put your final answer in standard form. This is from chapter 8. So 10 and 11, what we just need to ask ourselves is, what is the problem asking me to do? For instance, in number 10, it looks like I have a binomial minus a trinomial. So we do not need to do any distributive property. When I'm subtracting, all we're eventually asking is to combine like terms. I guess technically we do need to distribute one thing. This is really a negative 1 in front of this parenthesis, so we could multiply everything here by a negative 1 first. So I'd have a negative 10y squared plus 5y cubed. Then when I multiply by a negative, all the signs change. So we now have a negative 7y cubed, a positive 9y, and a positive 8y squared. Now, if I want to combine like terms, we can only combine things that have the same base and exponent. So these would be considered like terms because they both have y to the third attached. There are negative 2y to the thirds. I then can combine negative 10y squared and positive 8y squared to get negative 2y squared. And then 9y does not have a buddy to combine with, so it would just be there at the end in standard form. So that would be my answer for number 10. The reason that number 11 is on your review here is to remind you that something squared means the parenthesis 6y minus 5w times itself, 6y minus 5w. And so this ends up being the distributive property. The 6y would distribute to both terms. 6y times 6y is 36y squared. 6y times 5w would be a negative 30. You could write yw, but I'm going to go alphabetical and do wy. Then if you distribute the negative 5w to both, we have another negative 30 wy. And then negative 5 times negative 5 is a positive 25 w squared. Apologies for it going off the page a little bit. So now I notice that I have some like terms in the middle here, the wy's. So my final answer would be 36y squared minus 60 wy's. Remember, the exponents do not change when you're adding, only when you multiply. And then plus 25w squared. Yes, this answer is in standard form because, again, as you may notice, the y exponents are going down, going from y squared to y to the first to no y's, and then you're going from no w's to 1w to 2. So this is in standard form. Numbers 12 and 13 are all about exponent rules, which is from chapter 7 this semester. And I keep putting these problems on your review packets because I feel like they could keep using work and help for you to study for your final eventually. Number 12 is asking you that, or telling you that everything inside here is being raised to the second power. So a lot of you like to think of it as that there's 1, 2, 3, 4, 5, 6 bases within the parenthesis, all raised to the second. So that would be 2 to the second, x to the, remember that if you're raising a power to a power, you're really multiplying the exponents. So x to the negative 6th, y to the 16th, over 5 squared, x to the 12th, y to the negative 20th. So now we applied the 2 to everything, and so now let's simplify what we can. The 2 squared becomes a 4, the 5 squared becomes a 25. These are like bases here, and so when you have like bases and you are dividing, you are really subtracting the exponents. So we get x to the negative 6 minus 12 power, and the y's are also like bases, and that will be y to the 16 minus a negative 20. So if I continue to simplify, we would get 4 25ths. X to the negative 6 minus 12 is negative 18. Y to the 16 minus 20 is really plus, so it would be y to the 36th power. Now, if I want this as a good final answer, all negative exponents need to become positive, so this would have to flip down. So my answer would be 4 on the top, y to the 36th power on the top, 25 remains in the denominator, but x to the 18th would flip to the denominator, and the 18 would become positive. So that's my final answer for number 12, because I cannot take anything else out of 4 and 25. Number 13, same idea, except for this time we're not dividing, we are multiplying. But you want to look at the parentheses first. My eye goes here. There are 2 bases within this parenthesis, so I'd have negative 6 squared and then x squared. And I'm just going to recopy everything else that I see. The negative 6 squared, remember negative times negative is positive, so we'd have 36 x squared y to the negative 3rd times 2x to the negative 7th y to the negative 11th. If I'm thinking like terms at this point, the 36 and the 2 are asking to be multiplied, so 36 times 2 is 72. If I think again like bases, x squared and x to the negative 7th can be combined, and I would add my exponents, 2 plus negative 7, and my y to the negative 3rd and y to the negative 11th is y to the negative 3 plus negative 11. So I have 72 x to the negative 5th, y to the negative 14th power. Now this time I have 2 things with negative exponents, so both need to be flipped down. So that means that the 72 has an exponent of 1, so it does not flip, so it remains in the numerator, but the x to the 5th and the y to the 14th flip to the denominator. So this would be my final answer for number 13. And this is where the second video is going to end. I will continue with number 14 on video number 3. Thanks, everybody.